All right, welcome to the Explainer. Today, we're going to break down a concept that's absolutely fundamental to technology and business, data modeling. Think of it as the hidden architecture behind pretty much every single piece of software you use, and we're going to map it all out.
Okay, so let's just dive right in. I want you to think about something for a second. If you were building a house, a really solid, reliable house, you wouldn't just show up and start throwing bricks together, right? Of course not. So why would building something with pure information be any different?
The answer for both is exactly the same. You start with a blueprint. You need a super detailed plan that shows what you're building, how all the pieces are going to connect, and where everything needs to go to make sure the whole thing is strong and, actually works.
And in the world of information, that essential blueprint is called a data model. It really is the master plan that everything else gets built on top of. So let's take a closer look at what that really means. So here's the crucial thing to get. A data model isn't the database itself, not at all. It's the design for the database. It's the formal plan that data modelers and business folks create together, making sure that the final system does exactly what the business needs it to do.
Now, what's so cool about this is that any data blueprint, no matter how ridiculously complex it seems, is actually made from just 3 fundamental building blocks. Once you get these 3, you really understand the heart of data modeling.
First up, we have the entity. These are the main subjects in our data world, the real-world things we need to keep track of. Put simply, they're the nouns of our system, like customer or product.
Next, each of our entities has attributes. These are all the specific details we need to know. So if customer is our noun, then attributes like name or customer number are the adjectives that describe that noun. You can just think of them as the columns in a spreadsheet.
And the third piece, which is really where the magic happens, is the relationship. These are the verbs that connect our nouns. They define how all those different entities interact with each other, turning what would be just a list of things into a connected, logical system. And this table right here illustrates it perfectly. See? We have a customer entity and a product entity. Well, the sale entity is created specifically to record that interaction, the relationship between them, by grabbing their unique IDs and, of course, the date of the sale.
Okay, so let's talk about the actual design process. A data blueprint doesn't just appear out of thin air all at once. It evolves through 3 very distinct phases. A lot like how an architect's plan goes from a really rough sketch to a detailed guide for the construction crew.
This 3-step process is how data modelers make sure they get everything right. They start broad, with a business-focused chat, and then they keep adding layers of technical detail until they have a super precise, ready-to-build plan that developers can actually use. The whole process kicks off with the conceptual model, and honestly, this phase is all about the what. It's a high-level conversation, usually between the designers and the business teams. We're just trying to agree on the main entities and how they relate without getting bogged down in any of the techie stuff. Next up, the logical model. This is where we start adding that technical detail. It becomes a complete blueprint that any database builder could pick up and understand, no matter what tools they like to use. We define all the attributes and figure out how each entity is uniquely identified and linked. And finally, the physical model. This is where the rubber meets the road. It adapts that blueprint for a specific construction site. In our case, a database system like Oracle or SQL Server. This is where we define the exact data types, indexes, and all the other nitty-gritty details to make sure the system runs fast and efficiently.
So, how do data architects actually draw these blueprints? They don't just write it all down in a big text document. Nope, they use a standard visual language to map everything out so everyone can see it clearly.
The most common format for this by far is the entity relationship diagram, or, as pretty much everyone calls it, an ERD. It's basically a flowchart that shows how all of our entities relate to one another inside a system. And ERDs use these really simple standardized symbols, which makes them super easy to read. Rectangles are for our entities, ovals are for their attributes, and these diamonds show the action or relationship that connects them. Simple as that.
Now, there's a key concept shown on these diagrams called cardinality, and this is really important. It defines the numerical rules of a relationship, things like one-to-one or one-to-many, which are basically critical business rules spelled out visually. And to show these rules, special notations, often called crow's foot notation, are used on the lines connecting the shapes. They show with total precision whether a relationship is mandatory or optional, and whether it involves just one item or potentially many items. So you might be thinking,
Wow, that is a lot of trouble to go through. Why bother with such a detailed blueprint? Well, just like with building a house, all that planning pays off big time in the long run.
For one, it forces everyone to be crystal clear and consistent. You get this predictable map of all your information, which is just invaluable for spotting problems like duplicate data or missing information before you ever start building anything. It also becomes a universal language. Your tech teams and your business teams can use the model to communicate without misunderstandings, making sure the final system actually enforces the real business rules everyone agreed on from the start. And crucially, this is the big one. A good blueprint saves a massive amount of time and money down the road. Future upgrades become so much simpler and faster because the whole system is built on a stable, well-documented, and scalable foundation. So the next time you open an app, any app on your phone, just think for a second about that elegant blueprint working underneath it all. The entities, the attributes, and all the relationships that make everything work so seamlessly. What do you think the blueprint for your favorite social media app looks like? It's kind of fun to think about. Thanks for exploring this with me.